Hello everyone, and welcome to a fascinating comparison test between variously priced brake pads. In this video we have 5 different sets of brake pads, all of which are for the front brakes of the same model vehicle, but which are made by different companies, and as you can imagine, sold at very different price tags. If you've ever purchased brake pads from your local parts store, you might see labels that indicate lower, middle, and upper tier brake pads. These are the first 3 pads we're testing, with the budget option costing less than $20, the mid-level costing less than $40, and the upper-level priced brake pad under $60. The other 2 pads to be compared are more expensive options, one from NRS Brakes, who is the sponsor of this video, as well as the original equipment brake pads from the vehicle manufacturer, to compare against the other options. Now yes, NRS Brakes is involved in this comparison and they're also sponsoring the video. However, without access to their test equipment and facility, I wouldn't have been able to perform any of these tests as it requires unique and expensive machinery. The differences between bottom, mid, and upper level pads will become apparent regardless, and each individual brake pad will undergo the exact same testing. Ultimately, the question we're answering is, when I walk into a parts store and buy brake pads, am I getting a better product by spending more? We'll also be discussing what visual features you can look for on a brake pad to know that it's high quality and discussing why it's actually better. So, each of our 5 sets of brake pads underwent 4 separate tests. First, a performance test that looks at the brake fade and friction coefficients of the brake pads. The same pads used for performance testing then undergo a corrosion test cycle, and finally, the pads are subjected to a shear test. The shear testing is also done with an additional set of new pads, and our final procedure, noise testing, is completed with new pads as well. Starting off with performance testing, this is a standardized test, SAE J2522, and it includes a series of 15 test cycles ran sequentially. The test is used to determine the effectiveness of a brake pad's friction material with regards to pressure, temperature, and speed. The results show interesting differences between the pads. We're going to skip over the first 8 test cycles, as these involve the bedding process and brake cycles at speeds that get progressively faster. What's really interesting are sections 9 and 14, where we get into brake fade results, in this case for our budget brake pads under $20. This test can tell us what brake pedal effort will actually be required by the driver in various scenarios. So it looks like a confusing mess of information, but let's break it all down. At the bottom, we have our number of brake applications, in this case 15 separate stops. For each of these 15 stops, we're measuring the brake pad temperature in red, the amount of brake pressure required in green, and the frictional coefficient in blue. All 15 stops are from 100 kilometers per hour and bring the rotor down to 5 kilometers per hour, while deceleration is held constant at 0.4 G. You can think of this as a pretty aggressive stop, but not a panic stop. Obviously, as you continue to run the test, the brakes continue to get hotter and hotter, seen in red. Less predictably, the frictional coefficient in blue can increase or decrease during this test. As the mating surface of the pad improves, the frictional coefficient may go up. As the pad heats up, the frictional coefficient may decrease. The amount of pressure applied can also change the frictional coefficient in either direction. But what this graph makes very apparent in green is that the amount of braking pressure required to slow down at the same rate increases dramatically as the brake pad gets hotter. On top of this, the range of brake pressure is massive. So what does this mean? Well, when you start braking, you're applying a certain amount of pressure with your foot, but by the time you've stopped braking, the pressure has nearly doubled, meaning you have to press twice as hard just to maintain the same stopping power. This will give the driver a very uncertain brake pedal feel. NRS believes you don't want to see the frictional coefficient dip below about 0.2, which you can see does happen with the cheapest brake pad. When the frictional coefficient is really low, it means the driver will have to press the brake pedal harder to slow the car down. Comparing this to mid-level, upper-level, NRS, and OE brake pads, we see quite a variance in how all of these brake pads react under high temperatures. The cheapest pad is the only one where the frictional coefficient drops below 0.2, though the upper-level pad gets close with a minimum at 0.23. But analyzing the green curve lets us know about what the brake will feel like to the driver and how predictable it is. Ideally, you want to see the green curve remain fairly consistent, and you don't want a large range between the pressure required at the beginning of the stop and at the end of the stop. Going back to our cheapest brake pad, this massive range means the driver will have to exert significantly more effort for the same amount of braking, and it won't feel intuitive because it changes at various temperatures. Looking at the NRS pads, the curve remains pretty level, and the range isn't large. If you were driving on a track, you'd notice a consistent, predictable response from these brake pads. By the time we get to the second fade test, section 14, our friction material has stabilized. We're running the same cycle as before, and you'll notice across the board there are major improvements. The cheap pad consistently stays above 0.2 for the frictional coefficient. However, by the end of the test, you can still see that the driver will have to press the brake pedal twice as hard to slow down at the same rate. The OE pad looks to be the best here, where brake pressure remains very level throughout the entire temperature range, and the range of brake pressure from start to stop is very small. Super predictable, consistent pedal feel for the driver. The upper tier parts store pads also did very well in this test, though the initial characteristics of the pad varied quite a bit. Overall, the performance testing only made me majorly concerned about the budget pad, though the mid-tier pad also had a lot of variance in the initial testing. The NRS brakes showed the best initial results and remained the most consistent between the initial results and when the friction material had stabilized, and the OE pad showed the best results once the friction material had stabilized. Of course, drivers out in the real world could be driving with brake pads in any range of these conditions. Another critical aspect of performance testing is how much the brake pads wear. Consider that if a cheap pad's friction material wears very quickly, you'll have to replace it more often, and thus it might not even save you money in the long run. For each pad, the thickness was measured in 8 locations before and after performance testing. From these measurements, we can determine how much of the brake pad remains. The budget pads had 85.7% of the friction material remaining, the mid-tier pads had 89.7% of the pad remaining, the upper pads had 85.8% left, the NRS pads had 87.2%, and the OE pads had 89.3% remaining. These results are the average of 4 brake pads tested in each category. With all of the pads having over 85% of the friction material remaining, it may seem like there's not a lot of difference here, but consider that these numbers show the budget pad has nearly 40% more wear per test cycle versus the mid-tier pad. Now, I want to make something very clear. How long a brake pad lasts is not simply a function of how quickly it wears, as corrosion can cause a brake pad to fail long before it has worn down, as we'll see in the next test. Moving on to corrosion testing, we take the same pads used for performance testing, and now they soak in a corrosive mist for 24 hours. This is an accelerated test that represents 2 months of brake pad use in harsh winter conditions. The brake pads are placed in the chamber at an angle so any moisture drips off and new mist continues to accumulate as the salt spray is continuously applied through the entire chamber. Car manufacturers will specify that their original equipment brake pads last for a certain duration in this test without any visible red rust. NRS Brakes has an internal requirement that their pads must last at least 24 hours without any visible rust. The bottom tier, mid tier, and upper tier part store pads all had visible rust, while the NRS and original equipment pads did not. Looking at the cheapest brake pad, the rust was substantial, and it even crept in behind the friction material. The performance testing broke down the glue because it was so hot, allowing for the moisture to creep in behind the pad. And because the brake pad isn't galvanized, rust very quickly starts to work its way in. Rust jacking will eventually force this material off of the backing plate, and you can end up with pieces of the brake pad falling off. To prevent this, NRS uses burrs that mechanically lock the friction material to the backing plate. The backing plate is also galvanized, meaning a layer of zinc covers the surface, acting as a sacrificial barrier to prevent the pads from rusting. And as you can see, the galvanization prevented rust from occurring in the corrosion test. The OE pad also didn't have any rust, as it too is galvanized and then painted over. The tricky thing here is that the cheaper pads will just be painted, so you can't see if they're galvanized underneath the paint, and the paint alone won't offer much rust protection, as we see since the lower, mid, and upper pads all had rust, all were painted, and none of them were galvanized. NRS chooses not to paint their pads so that you can visibly tell by looking at it that the backing plate is galvanized. Overall, only the NRS and OE pads passed this test. Next, we move to the shear test. This test shows how well the friction material is attached to the backing plate by applying pressure to the friction material until it is removed. For each of our 5 different brake pad categories, we tested 4 brake pads, 2 that were brand new, and 2 that already had undergone performance and corrosion testing. The brake pad is placed into a device that secures the backing plate, but leaves the friction material exposed. A shear tool is then placed, which applies pressure to the backing plate. If you're wondering why pressure is applied vertically onto the pad material rather than from the side, which would be more representative of a brake rotor and pad interaction, this is done to allow for consistency in testing. If the shear test were done from the side, some pads would have different chamfers and rounded edges, so the industry standard is to test against the top, where the entire pad depth can be pressed against. The machine used for testing measures the maximum pressure applied before the brake pad material fails and shears off. So, how did the different pads do? NRS states that the original equipment suppliers generally want to be above a minimum of 3.5 megapascals before failure. Brand new, none of the pads had any trouble meeting this standard. However, it is surprising to see how well the budget and mid-level brake pads did compared to the more expensive options. After the brake pads undergo performance and corrosion testing, however, the results change. The budget and upper level pads both dip below 3.5 megapascal, while the mid-level, NRS, and OE pads all remain above 3.5. Again, surprisingly, the mid-level pads actually did the best in this test. An important distinction here is that you want the friction material to be the failure point, not the adhesive used to attach it to the backing plate. You can see that with the budget pad, the adhesive was the weakest link, as the pad was cleanly sliced off. This is why NRS uses mechanical burr locks, which means the friction material's bond with the backing plate will not be the failure point. Now, there was one final test all the pads went through, and this was entirely separate from all the previous tests. Brand new pads were used for noise testing, where brake pads underwent 1,430 separate braking applications, and the peak noise level is recorded for each braking application. Ideally, you don't want any noises above 70 decibels, so out of the 1,430 stops, the number of stops that peaked over 70 decibels as well as over 80 decibels were recorded. This test showed quite a separation between the budget and mid-level pads and the rest of the pack. The budget pads had 69 total stops over 70 decibels, and 35 of those stops were above 80. For the mid-tier pads, 50 total stops over 70 and 27 above 80. For the upper tier pads, there was only 1 stop above 70 decibels, and it did not exceed 80. For the NRS pads and the OE pads, over the 1,430 stops, neither had any noises exceeding 70 decibels. So let's go through each of the individual pads and see what we learned. With the under $20 budget pads, they experienced the most brake fade and required the highest brake pressure in order to stop. And even though they were painted, they experienced the most corrosion from the salt mist, indicating that paint on the exterior alone does not mean the pad is safe from corrosion. It does have a decent shim that wraps around the backing plate, and it did pass the shear test when new, however it dropped below 3.5 megapascal after corrosion testing. This pad also had the highest number of noisy stops. Overall, there's a clear indication that in this case, you get what you pay for. Spending a bit more in the $20 to $40 range, the mid-tier pad also had some strange braking behavior, though that mellowed out by the second round of fade testing. It did have rust, though not as bad as the cheapest pad. The shim wraps around the edge, which is good to see, and surprisingly, this pad did the best overall in the shear testing, though it was also significantly noisier than the more expensive options. The upper level pads, priced under $60, showed less brake fade and a very consistent result on the second brake fade test. They rusted considerably more than the mid-tier pads and had the worst overall result in the shear testing of the corroded pad. Also, the shim on the backing plate has a poor design that doesn't wrap around the pad. If this were to dislodge from the pad, it can easily act like a cutting tool, damaging the brake system as the rotor spins. It's best to avoid using pads with shims of this style. These pads did, however, do exceptionally well in the noise testing, perhaps the only characteristic of the pad where it seems to have a leg up. The NRS pads, representing our over $60 category, showed a very consistent brake pedal feel in the brake fade test, maintaining a high frictional coefficient. The visibly galvanized pads did just fine in the corrosion test, as the zinc prevented rust from occurring. Mechanical burrs used to lock the friction material to the backing plate ensured it exceeded the 3.5 megapascal requirement in shear testing, and these burrs also prevent rust jacking like we saw with our cheapest pad, where the rust crept in behind the friction material. Finally, we have our original equipment pads. These showed a bit of variance in the initial brake fade testing, but by the second round had a very smooth, consistent pressure required. They didn't rust, they passed the shear testing, and along with the NRS pads, they were the quietest of the group. These pads make it apparent that by the manufacturers setting standards and requirements for their pads, the quality of the pad will be strong, though of course this will come at a higher price point. Overall, this was a fascinating comparison among the many various prices you'll find brake pads at. I've always wondered what's the actual difference when I walk into a parts store and they offer me 3 different tiers of brake pads, and if there really are any differences. Turns out, yes, quite dramatic differences. A huge thanks to NRS Brakes for allowing us to use their facility to complete all of these tests. Their team put a ton of effort into getting this testing completed, and I'm thrilled I get to share this information with you all. It was truly a special experience getting to tour the facility and observe the equipment used for testing. If you're interested in getting galvanized brake pads for your car, you can check out their products at nrsbrakes.com. If you have any questions or comments, of course feel free to leave those below. Thanks for watching.